welcome. In this lecture, I want to go through an example of proving that a function is not injective. And logically, I think it's going to help to write the definition. It has a logical structure to it that I didn't use when I first stated the definition. So I'm going to write the definition with that logical structure so that it's easier to see how to prove this. So f from s to t is injective if and only if, I'll write like this, the following statement holds. Okay, so it's going to be an if-then statement. So if S1 contained in S2 satisfy S1 does not equal S2. Okay, so if those are two distinct elements, then we're going to have that f of S1 does not equal f of S2. Then f of S1 does not equal f of S2. Right. We could also use this implies statement. Okay. So how do you actually prove a statement, an if-then, disprove an if-then statement, right? Because we're trying to show it's not injective. So what you need to do is to find a circumstance where this holds, but this does not hold. Okay. So this is what we're going to do. So here we go. So claim the function f from the integers to the integers defined by f of x equals x squared is not injective. Okay, so what are we going to do? We're going to state an example where this holds, but this does not hold. Okay, so proof. We know that f of 1 equals f of negative 1. And 1 minus 1 are integers. Okay. But one does not equal minus 1. Okay. That's it. That's all we needed. Okay, so let's kind of like break this down a little bit. So we know that, so what did we say? We needed, it's this one satisfy this. Okay. So the first part is need that S1 equals 1 and S2 equals minus 2 satisfy. So let's find that in our proof. Okay, so we have, so they're in the set and they're not equal. Okay, but we need that. So we need that this fails. So we have to look for where that goes. So where does that fail? So this is precisely this part right here. That's all we did, right? Because they're equal. They're not equal. They're equal. Okay? So that's all you do when proving that something is not injective. You have to show that it satisfies this part without satisfying that part. Or in other words, you find two elements who give you the same output but are distinct. Okay. By the way, the part of their being distinct is obvious here. There are times when there's actually something to show in that because you might have written the same thing in more than one way. An easy example to think of is something like the rational numbers, where you can write a rational number in many different ways. And so you might actually need to be, first point out that even though, that there's no sneaky equality in there, I'm not talking about 9 over 3 and 6 over 2. Okay? So I hope that made some sense, and I will see you in the next lecture.